Then one sample test we have where we test our current sample mean with a earlier available mean data points. Let's take an example. So past year we had one data set where we said the plant performance was 100 per plant. This production unit you can see 100 per plant after the optimization event. Recent performance was being observed for 25 days, indicating that the average performance is 130. With the standard deviation of 15, did you optimize the work? That's a test we are testing. So null hypothesis would be status quo, which means there is no change. We are still on 100 per plant. That's a observation that we are taking $1 as an given a value to the give the currency value to the outcome. So we are testing whether it's greater than less than case. So greater than it means left side tail would be get validated. If we have less than case, we will be validating our right hand side tails. So we have a two tail test also available. So here we are saying right. My bad. Let me repeat it again. So when we say that we are validating on the right hand side, we are validating greater than case. When we are validating less than case, we are validating on right hand side case. So it means if I draw it likewise, you can Google the tables, the tests. So we have tests like this. So currently we are not doing on the right side testing. It means we are validating for the greater than values. If you are saying we are validating on lower values, so we can go for the left side test. Left side table you can see, then right side table would be for greater than cases. And if you're using both tails, we would be getting a threshold. This threshold would be what? Coefficient intervals. Under this, if we are getting values, we are saying null hypothesis is true. We're using two tail test. In that case, we can do like this. Otherwise, greater than values would be get validated on right side test, and less than value would be get validated from left side test. It means if we are getting negative values, we'll be validating from the left side table. If we are getting positive values and outcomes, we are validating would be right hand side test. That's a thumb rule you can follow. Rest you can go in nitty-gritties when you go for detailed documentation per se. We can go for further detailing to this. So currently we are saying that's validate from the greater than case. Okay. So formula would be like this. So you can see the formula is different for each use case. Here we are saying as we have already population available, population mean is available, and this data is being validated with the sample set. Standardization we have for the sample set and root of n of samples available. So if you read the question clearly, so we are saying the sample mean is what? 130. Population mean is which was reported earlier was 100. Standardization which is currently reported as a 15, and observation which we had been tested is 25 units or 25 observation we have taken consideration. If we run this formula, we are getting 10 as an outcome. That's a T value, calculated value. And degree of freedom we have is 25 minus 1, 24, and alpha we are testing on 0.05, that's 5%. The critical value table or again table value we are getting is 1.711, which means our predictive value is less than the value which we observed, which means our alternate hypothesis is stand true, which means we are rejecting our null hypothesis. Statement is what? If your calculated value is less than the p-value, or you can say critical value we received, null hypothesis is likely true, but in my case it is false, as we are getting a calculated value which is larger than our critical value or table value. We are rejecting null hypothesis in this case, and we say there is a improvement available. So as my value is in positive case, so we are validating on the right hand side tail data set, and if it is negative, we would be validating on the left hand data tables. So if you want to verify this, we can verify this also on the same tables. So degree of freedom is what? Let's observe on 1, 2, 3, 4, 5. Okay. 23, fifth column. 23, fifth column, we are having value like this. That's it. Outcome of table. So critical table values, we can sometime we get into the documentation like critical values. That's a use case to validate our t-tests.